All right, this is the ratio test. And so what we're going to be doing is taking our general term a sub n, and we're going to be making a ratio out of it with a sub n plus 1 over a sub n. And so what that represents is a term and then the following term. And we make that ratio, and if it's going to give us some limit, and if that limit is less than 1, we say it's absolutely convergent. If it's greater than 1, we say it's divergent. And if it's 1, well, we need to figure out another test to use, not this one. What's happening is what we're doing is making this into a ratio. And you've already seen that before with our geometric series. So when we created the R, right, it was just a lot more obvious. We'd have something like 3, 6, 12, 24, ... and then that would be a sub n plus 1. That's where they come into play. So if you wanted to find out what the ratio is, you would always just take the term and divide it by its previous term. So like this. This is 12, and then we have a sub n plus 1 over a sub n. And so if it's geometric, we had that common multiple, that ratio, which is 2. And then we could look at it and see, oh, okay, well, if that ratio is less than 1, then our geometric series would converge. And if that ratio is greater than 1, then our geometric series would diverge. That's what we're doing here. So what we're doing is creating a ratio by dividing the previous term, by dividing the term by its previous term, right here, a sub n plus 1 over a sub n, and we're putting absolute values around it to say that it's absolutely convergent. So we're making a ratio out of it. That's all. So let's try one. So we have n to the 10, and so on the top what we do is we just take that n and we add 1, like that, and we put it in parentheses. And so we do the same thing up here. And it's really good to just write it out like this. I know you could probably just say n plus 2, but just leave it alone. And then what we're going to do now is divide that by the original a sub n that's in there. So n to the 10, negative 10, n plus 1, and then we put an absolute value around it. And now we're going to be taking the limit of this, but we're going to do some simplifying first. So we're going to simplify all of this and then take the limit. It'll give us an L, which again is that ratio. And if that ratio is less than 1, then we're going to be having converge. And if it's greater than 1, it'll diverge. And I'll show you all of this with Desmos, and hopefully it'll make a lot more sense. All right, so let's do some simplifying now. So we have n plus 1. And all we do now is use our fraction rule, which is whatever you're dividing by. So we're dividing by this guy right here. This is our denominator. And so we're going to flip them. So we get 10 n plus 1 over, oops, now we're going to flip it, times, and then we say negative 10 n plus 1 over n to the 10th. And so they should always be opposite like this. And now it's cancellation time. So this would equal, let me shrink this real quick. There, that looks better. So if you have n plus 1 to the 10 and n to the 10th, those both have the same exponent. So we can use our rules that we've used before, and that's just to put them both in the same parenthesis like that. And then these are just canceling. So we're going to write negative 10 to the n plus 1, and then we're going to write negative 10 to the n plus 1 times 10. So that whole rule, that plus 1, means we're adding them. And I got to put a parenthesis around it. And then we'll go back and bring the absolute values around it like that. All right, now it's just cancellation time. So those cancel. And so we end up with, this would just be 1/10, because the absolute values, times n plus 1 over n to the 10th. And then I'm going to actually divide these because I want this to be a fraction when I take the limit, because we're going towards infinity. So the limit as n approaches infinity, and put the 1/10 on the outside because it's a constant. And we get this. N divided by n is 1. And then we get 1 over n to the 10th. So that would be 1 and 1 over n. And then using our limit rules, we know that goes to 0. So we end up with 1/10 times 1 to the 10, which is 1/10. And now we can go back and look at it, and we say, oh, well, that's less than 1, which means the series converges absolutely, or it's absolutely convergent. All right, so now if we check Desmos on this, So if I hit play, you can see that it converged. It's already converged here. We can keep more and more decimals. But if you notice, that ratio is giving us this, and you can see that is our 1/10. And so the way you can look at it is each next term that we add is 1/10 the size. So if I click on each of these, here you can go here, we have 0.124, and so we're going to take this term, multiply it by 0.1, which would be 0.012, and then we add it, and then we add it, and then we add it. And so you can see there's not much change after that, because we're only adding something that is 1/10 as small as the previous term. So if you think about just plugging in right down here, you can see it's as it keeps getting smaller and smaller, right? We're adding and subtracting those, and then after a while it gets to here. So if you just think of 0.145, we'll just make it 0.2. It's 0.2. And then what we're going to do is add something that is 1/10 as small, because that was the ratio that we got. So we'd get that. And then we're going to add something that is 1/10 as small as that. So you can see as we keep going and going, we're just going to keep adding something that's smaller and smaller. And so it's not affecting the number as much. It's only affecting the decimal places way, way, way at the end, and making the decimal places, well, they're a little bit bigger, but not giving us a number. So our series is converging. Now, this is saying it's absolutely convergent, so let's look at it as an absolute. And so it did the same thing. The only difference here is we're actually adding them. It's not that add subtraction going on here, but it's pure addition. But the same thing is going to happen. Our ratio is still 0.1, so it's 1/10 of 1/10 of 1/10 of 1/10 of 1/10 that we're adding. And so you can see the decimals at the very beginning start to change here. So this is our P sub n. That is our series. So that's n sub 15. So that would be 15 here. So that's s sub 15. And you can see how they're starting to shrink, and they're only changing here. You'll see how they start first changing here at the front. We have 37.6, and then those were changing, and now they've pretty much stopped, and now it's all the way down here. So by the time we get here, right, it's only 1/10 of something that's really, 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 really small already. It's not going to change much. So that's the whole idea. We're creating a ratio and looking at it and basically using our geometric series on these. All right, so let's try another. So these are just basically now figuring out how to simplify them. That is what we're dealing with. So we're going to take -2 to the n plus 1 over n plus 1 squared. So again, all I'm doing is putting that n plus 1 in there. Let me zoom in and shrink this. All right, and so then we would have -2 to the n plus 1 squared. And again, we flip. And so this is not n plus 1, just n squared. There we go. Exact same term goes on the bottom, n plus 1 on the top. And then we flip them. So we would get -2 to the n plus 1 over n plus 1 squared times, and then n squared over -2 to the n. All right. Now we do that same thing we did before. So we'll take these two and cancel with them. And then those two are the same. So n over n plus 1 squared times -2 to the n times -2. And then -2 to the n. I'll put the absolute values back around it in a second. So you can see it's that same basic concept that we did before. All right, so we end up with now these canceling. A -2 just becomes 2. So we end up with n over n plus 1 squared. All right, so now it's limit time, because that's our thing. We got to do limit. So 2, limit as n approaches infinity of n over n plus 1 squared. And again, we'll rewrite it. And so this would just become 1 over n squared. So that's 2 times 1 squared, which is 2, which is greater than 1. So if it's greater than 1, the series diverges. This is divergent. And the last one was absolutely convergent. All right, and that same idea that we did before, let's look at it with Desmos. So if I hit play, you can see this guy's just going off to infinity. He's alternating between positive and negative, right? Because we're adding, subtracting, adding, subtracting, adding, subtracting. See, what we're adding or subtracting is twice the previous term. So if you just think about it this way, what was that one right there? Just say 50, right? So this is the sum of all of them, right? And so the next term that we are going to add, right, was twice whatever the term was before this to get here. And so you can see that's why it's going to get more negative, and then we're going to get more positive. So we're adding and subtracting twice the previous term. And so they're just going to get really, really big. And if you look at absolute value, the same thing is happening. So it's just growing exponentially here, right? Our series. So it's divergent. All right, let's try one more, this time now with a factorial. So we write our -3 n plus 1 over 2, and then you got to put n plus 1 now in place of the n like that. It's just like functions, like doing a composite function. You got to plug them in all over, and then we rewrite it. Okay, so now we're going to do our flip, and when I do that, I'm going to also multiply that out. So this is -3 n plus 1 over 2n plus 3 factorial, and then times, that looks horrible. Let me move it over a bit. Not that my writing's anything special to begin with, but I can make it better. I might as well. All right, there we go. It needs to look at least like a fourth grader's handwriting. All right, so we have 2n plus 1 factorial. All right, so we're going to do the same thing with these, just like we've done, is we're going to take and rewrite it with a -3 to the n times -3, and then put those two together in the same parenthesis. So this would be -3 to the n times -3. Sorry, not the same parenthesis, just so that we can cancel them. Okay, and that absolute value will turn that into a +3. Now with the factorials, we just need to make them match. And so the 2n plus 3 is bigger than 2n plus 1 because we've added 2 more to it. So that's the one you're going to expand. That would be 2n plus 3, and then you subtract 1. So 2n plus 2. And then you subtract 1. So 2n plus 1, and there it is. That's the factorial we were trying to get to. And just like before when we did factorials, these would just expand down exactly the same, but they are the same. So remember, this would just be 2n plus 3, 2n plus 2, 2n plus 1, 2n, and so on, but they cancel all the way down. And then now we're left with that. Now we take our limit. So the limit, let's try that again. The limit as n approaches infinity, and we'll put that 3 outside, just like before, of 1 over 2n plus 3, 2n plus 2. And again, n is greater than 1 here. So n being greater than 1 makes all of these positive, right? Because that would just be bigger and bigger. All right. But obviously that's 0 because the denominator has all those n's. And that's 0, which is less than 1. And so if it's less than 1, it is absolutely convergent. And so what this means is eventually our ratio becomes 0, and that's a very big, bad ratio. So let's look at Desmos. So let's hit play, and I've got an absolute value around it now. And so you can see, yeah, see how small the ratio is. So as we move through, the next term is a very small multiple of the previous term, getting really, really tiny. So it converged very, very quickly, right? And so we're only at 80 here, and you can see there's not much change in our sum since the beginning. So right after like 8, you can see that our sum here, our series is already pretty close. We already got a good approximation there, but yeah, it's getting smaller and smaller. So there you go. There's for your ratio. And so when you see things like that in this form with factorials and n to the 10 and -10 to the n plus 1, try the ratio test.